Hi, everyone. This is Miss Rapp, and this is Unit 6, Lesson 5. Unit 6, Lesson 5, solving systems with elimination. So we are still solving systems, so figuring out where two lines intersect, but now we're using a different strategy called elimination. This is standard 12, topic 3. I can solve a system of linear equations by elimination. So step 1, let's graph these. But before I graph these, I'm going to convert these into y equals mx plus b and see if that helps me. So 2x plus 4y equals negative 28. So I'm going to solve for y. 4y equals negative 2x minus 28. Divide by 4. Y equals negative 1/2 x minus 7. The other one would be negative 2x plus 3y equals 7. So this is a review from the previous video, solving for y. I get 3y equals 2x plus 7. Divide by 3. Y equals 2/3 x plus 7/3. There's my slope and my y-intercept. Okay, let's graph these. So negative 7. And then I'm going to go down 1 over 2. Okay, there's my first line. Let's try to do this one. So 7/3 is going to be tricky. So that's 2.33. So that's like here. And then I'm going to go up 2 over 1, 2, 3. So this obviously this won't be perfect. So let's draw our lines. Oh, actually, guys, I got it. I think I got it right on it. So it looks like they cross at -8, -3, maybe. It's kind of hard to tell because our y-intercept. So our graph isn't always super reliable. So now we're going to use another strategy. So this was our graph answer. This is our graph answer and our graph representation. So now let's try our new method. Write the two equations on top of one another so that the x's and y's and the constants line up with each other. Then add the two equations and solve the system. Okay, well, it says stack them and line them up. Add them together, so a big plus sign. So I'm going to combine like terms up and down. This is very new to us. Oh, so now I'm going to solve for y. I got y equals -3. And look, guys, that was our graph answer, so it's working. So now to find x, plug in y. So either equation, so I'll just use, I'll use this equation right here. So it'll be -3 equals negative x over 2 minus 7. So I'll add 7 to both sides and I'll get 4 equals negative x over 2 times -2 times -2, x equals -8. And that matches, oops, sorry guys, it's -8, -3. And that matches our graph. So even though our graph was sketchy, we still got it. But the big lesson from this example is sometimes your graphs are not reliable. Sometimes graphs aren't reliable, so you have to do your algebra work. Okay, moving on. I'm going to solve these. I'm going to rewrite these. So this would become, if I add the x over and divide by 8, that'd be y equals, would that'd be 1/8 x minus 5/2. And this one would be y equals 3/8 x plus 1/2. So these are really weird to graph. So negative 5/2 is 2.5. I'm going to go up 1 over 8. Down 1 over 8. So there's my first line, kind of, sort of. It's a little sketchy because of those fractions, but we're just going to try our best. And then 1/2 up 3, 1, 2, 3 over 8. 1, 2, 3 over 1, 2, 3. So like here, maybe? Let's see. Okay, guys, let's solve this. Maybe our graphs were completely wrong. Like, I'm doing this to show you that sometimes graphing gets weird. So maybe my graphs are wrong. Let's check it with the math. So it says, write the two equations on top of one another. So we're eliminating a variable. So like I just eliminated my y's. Oh, so I got x equals 4. So my graph was really off. And to find y, I'm just going to plug it in. And I got y equals 2. So our answer is 4, 2. So looking at, I trust the algebra more than I trust my graphs because of these sketchy lines. Okay, so sometimes your graphs aren't the most trustworthy. You got to move on and try the algebra. Okay, let's do number 3. So step 1, I'm going to convert these. So that would be y equals positive 8x minus 20. I don't think that's going to fit on here. So both of these won't fit. They won't fit. So I can't even use my graph. So we need to try our strategy. Let's try our strategy. So this is elimination. So we are going to write the two equations on top of each other in standard form. It has to be in standard form to do elimination. So looking at these, nothing eliminates, right? Because that wouldn't work. So I'm actually going to modify this top equation by multiplying everything by -1. So then the y's will cancel. So that becomes 8x minus y equals positive 20 plus -5x plus y equals -11. So this becomes, so my y's eliminate, which is good. 3x equals 9. X equals 3. Lovely. And to find y, let's just plug it in. I could plug it into any of these equations. I think the easiest one would be to plug it in right there. Y equals 5 times 3 minus 11. Y equals 15 minus 11. Y equals 4. So they would cross at 3, 4 is the answer. Okay, let's take a moment and do number 4. This will be our last problem. Remember, you have to have a positive and negative of the same thing for your elimination to work. Sometimes you have to modify. Don't forget to pause and rewind if you have any questions. Let's start problem 4. So I'm going to start by converting these. And for the first one, I get y equals 3/2 x minus 1/2. This is gonna be weird to graph again. And the other one I get y equals 3/2 x minus 1/2. If you are struggling with how I did this, obviously I didn't show you my work, go to Unit 6, Lesson 4, Part 2. The warm-up is this. Okay, so these are the same line, so they're going to be the same. Okay, so they're the same line, so our graph, it's infinite solutions, because they're the same line. Let's look at this in elimination. If I look at these equations, the second one is just the first one multiplied by 6. So if I wanted them to match, I'd say times 6. I get 6x minus 12y equals 6 plus, 18x. 18x minus 12y equals 6. Look, everything eliminates. 0 equals 0. True. Infinite solutions. So with elimination, you can have infinite solutions as well, and you can have no solutions as well. Okay, everyone, that was Unit 6, Lesson 5. Please go do the video check-in. Have a great day. Make sure you come to office hours. Ask your teachers any questions.